So I'm going to take a look at this AAA UPS today. I'm going to show how kind of these things are set up and how they work. This one's a not terribly old model. It's from like 2020-ish. And this is a 2000 VA, 2200 VA, about 2000 watts. I've started taking it apart because there's a bunch of screws hold these together. This one's got an LCD panel on it. It'll show you like the battery runtime, the wattage it's using, the kilowatts used for the day, the power site, the power fluctuations, things like that. These also have not all of them. This one did. They had a network card in it to manage it and switch a couple loads and monitor it. This particular one is a sine wave model, which you'll see in a minute. This one we pulled out of nowhere, just up and died. Sometimes that's the battery does that on these, but generally if even if the battery's bad, they'll keep running. So you just get a red light to change the battery. This one just up and died. I started moving things to bypass this, plugged it in the wall. Looks like it was going to work. Gave it 5 minutes, and then it just decided it was like the display was going all funky. And it's like it wouldn't turn on. The battery showed 48 volts. I tried a few other batteries with it. I could get it to run briefly on a 48 volt battery bank, like third time I tried. But then I put a couple 500 watt halogen lamps on it, and within and they were pretty good sized batteries, about equivalent to what's in here normally. In a couple minutes, less than that, it was like 10 seconds, a couple 500 watt lamps, this thing was dead. So there's something funky going on with this thing. Everything looks fine. I don't know what's going on. So I'm just gonna show how these things work. That's the cable for the display. They all seem to have the display in the front. I don't know why. It'd be nice if they had like a pin header or something to hook the display on. This thing, you remove a couple screws in here and a couple here, and that's where the battery would get pulled out of. Because these run, some of them depends on the model and the size. Some run on 12 volts, some run on 24, maybe for 1000 watt. Usually these big 2200 watt models are 48 volt. Thunderstruck because it's dead. And let's take a look inside this thing. So that's where the batteries would go. They use pack of, most of these have like a pack, they're either glued together or kind of a plastic, thin chintzy plastic case of 4 12 volt, like 7 to 9 amp hour lead acid batteries. Newer ones are lithium ion, but those are kind of pricey still. If you want to get fancy, they also have super capacitor models, but I don't believe those would probably run a whole lot. A fan, small muffin fan to keep the thing cool. This is kind of a giveaway. It's a 60 hertz model, this big transformer with the lead acid batteries in this in here. This thing weighs a good, I would say, 50 pounds or so. And there's the control board that runs the thing. Those heat sinks are the driver transistors. These yellow and brown wires are to the transformer. High current, low voltage DC. 48 volts, that's not kind of low voltage, it's not 120, but I'm not totally sure what these outer transistors do. They're bonded together, so I'm guessing it could be like a push-pull setup. With these do one half, these do another. I'm not totally sure what those are there for. There's a lot of capacitors here because it takes a, those would absorb the power in rush, so the batteries don't get so degraded, or I don't know if it damage them, but every time the transformer turns on and off with these MOSFETs, it's going to be pulling a lot of amperage from the batteries. These kind of smooth that out, make a more pure DC going into there and pulling off the batteries. There's a few fuses here, one there, a couple there. Those are probably the primary. Usually these have like two 30 amp fuses in parallel for some reason. These wires would be the 120 outputs to the outlets. White's probably neutral. Gray is probably another neutral, because those are the, assuming this standard follows a standard like power industry code. White or ground, gray is usually neutral, and in black would be hot. I'm not sure why they have three. Oh no, that one's right. No, they have three hots and two neutrals, I guess, so maybe one of them's sharing a neutral. There's a thermocouple here, or thermistor to measure the temperature. There's another one, looks like another thing over here. That is probably a winding from the looks of it. Probably to just sense voltages, or maybe charge the batteries. All these are buried back here. There's some relays there that switch the power from mains to the inverter output. And alright, I flipped the thing around. This might be an odd plug to a lot of people. This is a normal 120 volt plug. Or it's normal 120 volt, but it's 20 amps of a 15 amp. There's another similar one to this, but the flat blade's on the other side here. Over here, that'd be for a 240 20 amp. And here there's a hole here, that's an accessory slot. That's where the network card would have mounted in. There's a little tray that goes in. I pull it out so we can see the board. Tray would go in here. That's where you stick the management card in. And it has some kind, I don't know what that would be for the interface. It could be serial or it could be proprietary. The management cards on these things for some reason are kind of, for the simple circuit board, they're probably for the software, they're good, usually a couple $100. But for a remote site, that's kind of a nice thing to have. This particular unit also has COM ports, old serial that's kind of dead, USB to manage it hooked to a computer. That's for probably like a sensor, an environmental sensor, something like that. Some of these can have like temp probes, and then it hooks into the management piece. That's probably for like a twist lock plug. We don't have that in this model. A ground screw. This particular unit had these banks of 20 amp unswitched outlets here, and then that bank was 16 amp, this one was 12, and then these two, load 1, load 2, were switched, and we used those for things we wanted to reboot that might occasionally need a reboot from what we found from our experience. That way, at a remote site, we could reboot the devices without having somebody to go reboot it manually. PDU would also do that. This is a nicer setup for a simple couple devices, though. Here's the relays again. A few power conditioning choke devices. Another relay. And the purple wire goes to a relay there. the light goes to that relay. There's a choke on the side there. Gray goes into the relay down there. It looks like the black goes right directly to the board. So that might actually be a neutral. And then there's a black wire here. You can see goes off to the board here. There's a small relay there. There's a couple small relays there. That's for those switched outlets. A small transformer there. Can't really tell what that's for. It might just be to power the board. There's a ribbon cable there to hook the interface these two boards together. A little beeper there that squeals when it's on battery, or when it's about to run out of battery, or something's wrong with it. Though that doesn't always work either, when it just fails and doesn't do anything. There's no sign of any burned parts or anything, but I don't know, because one time I hooked the batteries to this and it had a spade terminal, and it just melted part of the spade terminal when I hooked it up. It could be those capacitors, but that's a lot of power for those little caps, so I think there might have been something else going on with this thing. It's out of warranty. From what I can tell, what we decided, it's not worth trusting this thing. So there's going to be parts. The inverter parts seemed okay, but it seems sketchy, and it's not really worth messing with. Possibly save the MOSFETs for something, assuming they're okay condition. These are kind of cool though. That's toroidal transformer, because usually they're like a square brick, not a round disc. That is because this is a rack model. And if this was a different model UPS with a modified sine wave, that is more like a square wave or switching mode setup. Those are more efficient, but there's some equipment, PDUs, things like that. PDU would trip out on this type, on a switching mode type setup. Servers don't usually care, because that's just a switching mode power supply. You're converting AC back into DC again there anyway. This would be, I don't know if it's really even critical anymore if you have a 60 hertz unit like this. But this type of inverter would be better for something like a motor, things like that that are expecting 60 hertz. Some motors can run other frequencies, but then you get into three-phase motors with VFD type setups, which is kind of a switching mode type thing too there, but those motors are designed for that. And in the transformer, just like any other transformer, you take low voltage to high voltage. Your lower voltage is going to draw more current, so that's why these big wires are that size. And then these are smaller, like 12 gauge for the 120. Or if you put 120 in here, which you could do, if you find the pair that puts out 120, you could put it in 120, and then you get out, say, 48 volts or 50 volts on these, and you would have more amperage. That is kind of how a welder works. You get low voltage in, or high voltage in rather, low voltage out, high current, and that's what you would use to weld with. When transformers like this are nice for making things, or it could even be like a ballast type thing, because AC, when the AC goes to a coil like this, the current gets limited. So it could also be like a current choke or something like that. It was going to go in e-waste, so at least save a few things maybe off the circuit board. The relay board might be, relays are kind of a dime a dozen, so I don't know if they're worth saving. MOSFETs aren't too bad to get, but if they're here and depending on how bad they are to get off, maybe. Thermistors, those are fairly easy to save, that one. There's one there too. Looks like a big resistor there, that might be worth saving. Clip these big wires off for the battery terminals. Save this thing, and then scrap the rest of this thing. And these, I don't know, they're 20 amp outlets, but you kind of gotta have a thing that place you have square sockets to put those into. And then probably save the cord too, because that's a nice 6 to 10 foot 12 gauge cord with a 20 amp plug on it. That's nice for extension cord or put it on a saw or something like that.